Welcome to our deep dive into soil and grain size analysis. Today we'll uncover the secrets hidden in your soil and how understanding these can help you achieve healthier plant growth and better construction outcomes. So whether you're a seasoned gardener, a construction engineer, or just curious about the ground beneath your feet, this exploration is for you. Let's get started. First up, let's talk pH. You might remember this from chemistry class. It's a measure of how acidic or basic something is. Now, soil pH is super important because it affects how easily plants can absorb nutrients. Think of it like Goldilocks. It can't be too acidic or too basic. It needs to be just right. Most plants prefer a slightly acidic soil, somewhere between 6 and 7 on the pH scale. But some plants, like blueberries, actually thrive in more acidic soils. You can get a simple soil testing kit from your local garden center. If your soil is too acidic, you can add something called lime to raise the pH. And if it's too basic, you can add sulfur to lower it. Once we've got the pH down, it's time to talk about nutrients. Plants, just like us, need a balanced diet to grow big and strong. There are 3 main nutrients that plants need in large amounts: nitrogen, phosphorus, and potassium. Nitrogen is essential for leafy green growth, making your plants lush and vibrant. Phosphorus is crucial for root development and flowering, ensuring your plants have a strong foundation and beautiful blooms. Potassium, on the other hand, helps with overall plant health and disease resistance. It's like the immune system for your plants, keeping them strong and resilient. But wait, there's more. Plants also need smaller amounts of other nutrients, known as secondary nutrients. These include calcium, magnesium, and sulfur. Calcium is important for cell wall structure. Magnesium is a key component of chlorophyll, and sulfur is vital for protein synthesis. These secondary nutrients play important roles in various plant functions, ensuring your plants are healthy and productive. A soil test will not only tell you your soil's pH, but also give you a detailed breakdown of the nutrient levels. This information is crucial for choosing the right type of fertilizer to amend your soil. By understanding your soil's needs, you can give your plants the food they need to thrive, ensuring a bountiful and healthy garden. We've covered the big players in plant nutrition, but now let's zoom in on the tiny but mighty micronutrients. These are like the vitamins and minerals for plants, needed in smaller quantities, but just as crucial for their well-being. We're talking about elements like iron, manganese, zinc, copper, boron, and molybdenum. For instance, iron is essential for chlorophyll production, which gives plants their green color and is vital for photosynthesis. Deficiencies in any of these micronutrients can lead to a whole host of problems. The good news is that most soils contain adequate amounts of micronutrients. Now let's get our hands dirty, literally. There's no better way to understand your garden than by feeling the soil with your own hands. Have you ever felt different types of soil and noticed how some are clumpy, some are sandy, and others feel smooth like flour? That's soil texture. Each type of soil has its own unique feel and characteristics. Soil texture refers to the proportions of different sized particles in your soil: sand, silt, and clay. Understanding these proportions can help you determine how well your soil will support plant growth. Sand particles are the largest, like coarse breadcrumbs. They don't hold water well, but are excellent for creating air spaces. These air spaces are crucial for drainage and aeration, allowing roots to breathe and preventing waterlogging. Silt particles are medium-sized, like granulated sugar, and they hold water and nutrients relatively well. This makes silt a valuable component of fertile soil. Finally, clay particles are the smallest, like powdered sugar. They can hold a lot of water, but can also become compacted, making it hard for roots to penetrate. The ideal soil texture for most plants is called loam, which is a balanced mixture of sand, silt, and clay. Loam combines the best properties of all 3 soil types. Loam provides good drainage and aeration, while still retaining enough moisture and nutrients for healthy plant growth. This balance makes it the perfect environment for roots to thrive and plants to flourish. Now, let's talk about the magic ingredient that can transform your soil from good to fantastic organic matter. This is the decomposed remains of plants and animals, and it's like a superfood for your soil. Think of organic matter as a sponge. It improves soil structure, allowing it to hold on to water and nutrients more effectively. Organic matter also provides food for beneficial microorganisms in the soil. Adding compost, aged manure, or cover crops are all great ways to boost organic matter content over time. Time to shift gears and talk about the bigger kids on the soil block, the coarse fraction, which includes gravel and stones. Now you might think of these as just inert chunks taking up space, but they play a crucial role in soil structure, especially drainage and aeration. Think of gravel as the scaffolding that creates larger spaces within the soil. These spaces allow for better air movement, which is essential for plant roots to breathe and for beneficial soil microorganisms to thrive. Good drainage is also crucial for preventing waterlogging, which can suffocate roots and lead to unhealthy conditions. While a certain amount of gravel is beneficial, too much can lead to poor water and nutrient retention. Understanding the role of the coarse fraction is particularly important in construction and landscaping. Now let's dive back into the fine fractions, sand, silt, and clay, and really understand what makes each of them unique and how they contribute to the overall personality of your soil. Sand, remember, is the largest of the three, like tiny rock fragments. It feels gritty between your fingers and doesn't stick together well. Sandy soils drain quickly, which is good for aeration, but can be a challenge in terms of water and nutrient retention. Next up is silt, the middle child. Silt particles are smaller than sand, so they hold on to water and nutrients better, but don't drain as quickly. Clay particles are plate-shaped and have a huge surface area, which allows them to hold on to water and nutrients like crazy. All right, time to put on our lab coats. We're diving into the fascinating world of soil analysis. When it comes to understanding the coarse fraction of our soil, we turn to sieve analysis. This method is essential for separating and categorizing soil particles based on their size. It's like using a set of progressively smaller sieves to separate the different sized particles. Each sieve has a specific mesh size that allows only particles smaller than that size to pass through. Imagine a stack of sieves with the largest openings at the top and the smallest at the bottom. This arrangement helps in systematically sorting the soil particles. We pour our soil sample into the top sieve and shake, shake, shake. The shaking process ensures that the particles are evenly distributed across the sieves. The larger particles stay on top, while the smaller ones pass through to the sieves below. This way, each sieve captures particles of a specific size range. By measuring the weight of the material retained on each sieve, we can determine the percentage of different sized particles in our sample. This data is crucial for understanding the soil's composition. Sieve analysis is particularly useful in construction and geotechnical engineering. It provides valuable insights into the soil's properties and behavior under different conditions. It helps determine the suitability of soil for foundations, roadbeds, and other applications where load-bearing capacity is crucial. Ensuring the right soil composition can prevent structural failures and enhance the longevity of construction projects. While sieve analysis is great for the coarse fraction, when it comes to the fine-grained world of silt and clay, we need a more sophisticated tool, the hydrometer. This nifty device measures the density of a soil suspension over time, which allows us to determine the particle size distribution. We mix our soil sample with water and a dispersing agent to separate the particles. Then we drop the hydrometer into the suspension and record the readings at specific time intervals. By analyzing the rate of settlement, we can calculate the percentage of different sized particles. Hydrometer analysis is particularly useful for understanding the settling characteristics of fine-grained soils. We've covered a lot of ground in our exploration of soil and grain size analysis, and like any good scientific adventure, we've encountered some technical terms along the way. Let's take a moment to define some of these key terms to solidify our understanding. First up is grain size distribution, or GSD, which is exactly what it sounds like, a representation of the different sizes of particles present in a soil sample. Next, we have the uniformity coefficient, or Q, which tells us about the range of particle sizes present. Then there's the coefficient of gradation, or CC, which describes the shape of the GSD curve. These terms might sound a bit technical, but they provide valuable insights into the behavior of soil in different situations. Thanks for joining us on this journey through soil and grain size analysis. Don't forget to like, subscribe, and hit the bell icon for more insightful content. And remember, the next time you dig in the dirt, take a moment to appreciate the amazing world beneath your feet.